Here we have another homework problem based on piecewise defined functions and graphs. We are given the graph, and our goal here is to write a piecewise function. So as we read from the left to right, we're going to encounter our first graph. So here's our first graph. What we want to do now is ignore our second graph and primarily focus on this first one. So when we're taking a look at this first graph, we can see that's a linear equation. So meaning we want some equation in the form of y equals mx plus b. So let's try to figure out what our slope is. So we just want to grab any 2 points on the graph. And we can see that we can pick this point here because it's clearly on the graph, and this end point here that's also clearly on the graph. So we're going to count the number of steps we go down. So we count 1, 2, 3, 4. This tells us we have a rise of -4. Then we count the number of values we go over. 1, 2, 3, 4. So this gives us a run of 4. So this tells us our slope is -4 over 4, which simplifies to -1. The next thing now we want to do is find our y-intercept, our b value. So our y-intercept, or our b value, we can see that on our graph, we actually do cross the y-intercept at the order pair 0, 0. So this lets us know that our b value is now 0. So this is good news. We can now write our equation. So our equation is going to be y is equal to -1x plus 0. Or this just clearly simplifies to y is equal to -x. And there you go. We have our first equation. Now, our job now is to figure out our domain. Since again we're reading from left to right, we see that the start of this graph starts around here, where this open circle exists. So then what does that tell us? That tells us that we need to have our domain value starting at -3, but since it's an open circle, we're not going to include -3. So that means we have -3 is less than x. Then as we keep reading from left to right, we can see that our graph is going to end at this ordered pair. That's 2, -2. Since it's been filled in, this tells us to include 2 in our domain. So to finish off our domain statement, we're going to include a less than or equal to symbol and a 2. And so that's our domain. Our first equation is going to be y is equal to -x, and our domain is -3, strictly less than x, and less than or equal to 2. So now let's start fresh. So when we're starting fresh, what we want to do now is ignore the first graph, or the first section, as we're reading left to right, because we've already covered that. So now we have another downward pointing graph. So we can see that this is a nice straight graph. So we're looking for another equation in the slope-intercept form. So y equals mx plus b. So let's now pick any point that we know on the graph. So we're going to count 2 units down, giving us our rise value, which is -2. We're going to count 2 units over, giving our run value, which is +2. So our slope for our second graph here is -2 over 2, or simplifies to -1. The next thing we want to do is to find our y-intercept. So for this one here, our y-intercept is going to be a little bit more tricky. The reason for this is because we don't know that our graph intersects the y-intercept, unlike our other one. So what we can do is extend this line out and use our slope counting backwards to figure out where our intercept is. So we can go back 1 unit, up 1 unit, back 1 unit, up 1 unit, and we see that we're going to have a y-intercept at 0, 5. Now we have our b value is going to be 5. So this is great. We now have our slope and our y-intercept. Our equation is going to be y is equal to -1x plus 5. Or this simplifies to just y is equal to negative x plus 5. And we have our second equation. Now what we need to do is figure out where our domain are. So let's grab this equation, start with a fresher graph so we don't have any of this extra stuff. We already know our first section, so now we're trying to find the domain for the second section. So now we want to find the domain for the second part here. We can draw a dotted line, and we can see that there's an open circle here, and it goes all the way down to 2. So what does this tell us? This tells us that we're going to start at 2, but not include 2, and then have our x values. So now we have a statement that says 2 is less than x. So as we continue reading our graph from left to right, we can see that our graph is continuous because there's an arrow pointing to the right. This now tells us that our domain is going to just be x is greater than 2 because it goes on forever, which is great news. So now we have our second equation and our domain that goes with it. So in order to finish this problem, what we're going to do is grab our equation for the first part of this piecewise defined function and grab our second equation for the second part of this piecewise defined function. So back on the first slide, we're going to grab our first equation. And paste it here. And then we go on previous slide and grab our second equation. And paste it here. So this is good news. Now that we have our two equations, we're going to write this as a single piecewise defined function. We're going to start off with f for function notation of x is equal to 2 sections. So in the first section is going to be negative x if our domain values is negative 3 is less than x or less than or equal to 2. And in our second equation, we're going to have negative x plus 5 if our domain values of x is greater than 2. And there we go. Here's our piecewise defined function based on our given graph, where our first section is defined as negative x, and our second section is defined as negative x plus 5. And huzzah, we're done.